Alright, in a moment I'm going to be moving on to the foldable, but first I want you to stop, grab your warm-up sheet, and I want you to do the same type of problem, but this time find the 6 trig functions if you have a point -3, -4 on the terminal side of theta. So stop this video, go do that practice problem, and then grab your foldable. So what we're going to be doing now is looking more closely at the quadrantal angles. So if you recall from the first video and from the back of your foldable, a quadrantal angle is a special angle that falls on the x or y axis. So we just figured out how to find the trig ratios of any angle anywhere in a whole 360 degrees except for these guys. These ones are special, so we're going to do them together in this foldable. Now keep in mind that I wrote degrees on here, but we want to start training our brains to think in radians. So this is also 0 radians, 90 degrees. Well, let's come back to that one. Most of you know 180 degrees is pi radians. And if 90 is half of 180, that means this is pi over 2 radians. And then this 270 is 90 degrees more than 180, so that's going to be 3 pi over 2 radians, because you add 1/2 pi plus pi to get 3/2 pi. Alright, so now let's go ahead and get started with what I really want to do here. If we have an angle that's 0 degrees, what that really means is the initial and terminal sides are on top of each other. Okay? I'm going to highlight that just so you can really see it. But our angle is on top of itself. Now, in order to find the trig ratios, we've always needed a point. In that last example, we needed a point xy. So I'm just going to pick an arbitrary point on my terminal side. Remember, my terminal side's on my initial side. So I'm just going to choose the point 1, 0, just 1 unit away from the origin. So now we have our x, it's 1, we have our y, it's 0, and we can calculate our r using that formula that I gave you. So even though we don't have a triangle, r can be calculated from x and y. So even though we can't see it, it's still there. So we're going to do the square root of 1 squared plus 0 squared, so r equals 1. So these 3 values are what we're going to use to determine sine, cosine, and tangent. If you open up your foldable, that's what you see here. Oops, these are supposed to say 0 degrees. My bad. Okay. So sine of 0 degrees. Look back at your ISN and you'll see that sine was y over r. So we need to look back and see our y was 0, our r was 1. So sine of 0 equals (0 over 1), which equals 0. Cosine of 0 equals, if we look back here, x over r, so 1 over 1. So cosine of 0 degrees equals 1. And then tangent of 0 degrees equals, and if we look at our notes, it's y over x. So we're going to have 0 over 1, which means tangent of 0 equals 0. Okay. So these are some facts that we need to memorize. They're going to be very useful to us because they're going to pop up in calculations that we do. So we will want to know that cosine of 0 equals 1, whereas sine of 0 equals 0. Now let's move over to the 90 degrees, or the pi over 2 radians. And let's do a similar thing. We're going to draw that angle. Here's our initial side and our terminal side. It's 90 degrees. We're going to pick a point on the terminal side, and this time we're going to make it 0, 1 unit away from the origin. So this time our x value is 0 and our y value is 1. And if we do our r equation, it's going to come up to be 1 again. So now we have those three values. We're going to go to the inside of our foldable where this is supposed to say 90. And we're going to find each of these. So sine of 90 degrees equals, our notes say y over r, so we got 1 over 1, that equals 1. Cosine of 90 degrees equals, if you look at our notes, x over r, that's going to be 0 over 1, so that's going to be 0. And tangent of 90 degrees, here's where it gets interesting. Our note says y over x, so we're going to do 1 over 0. But remember it said x cannot equal 0, y cannot equal 0, and r cannot equal 0 in the denominator. So when we come over here, we have 1 over 0. Well, that can happen. So tangent of 90 degrees is undefined. It doesn't have a value. So if this ever pops up in a problem, the whole problem is automatically undefined. So what I want you to do is now go and do these bottom two tabs on your own, and we will discuss them in class. But try to do the front graph, and then also try to find the values for inside as well. And I didn't have any typos here, so you should be good. Once you're done with that, glue it in on the bottom of page 30, and you'll be ready to go.